chronologically from the E system that we have determined before, we can simply rearrange it in order to determine the total number of PV modules. Okay, uh, this is just the rearrangement from the previous determined E system. Okay, so sometimes in certain question we don't ask you directly how to estimate the E system. We may ask you what is the total numbers that can be installed in order to achieve this kind of requirement. Like that, eh? So we are given you the E system instead, and then you need to find the what is the total modules that can be installed. Okay, okay. For better understanding, let's go through for the example of example 3. Okay, here let's say we assume that we have the detail of energy yield 10 megawatt hours, annual peak sun hours 1720 hours, solar radiance of 800 watt per square meter, ambient temperature of 32 degrees C, dead factor 2% and voltage drop 3%. And we have the PV module here where the P max or the PMP or the P mode STC of 240 watt. And we have the temperature coefficient of PMP here, which is the value is minus 0.45% over degree C. This is typical case for the monocrystalline based silicon modules. Okay, and then we have the tolerance of minus 3 plus 5%, and finally we get the NOCT of 47%. Sorry, NOCT of 47 degrees C. Say what should we do is clearly, because we are given already the E system, now the task for you is to find what is the N total. Okay, N total is the total number of modules that can be installed by this requirement. Okay, okay. We just substitute the value. E systems clearly is 10 mega hours, which is equal to this value. And then next is the P mod STC that I told you is the same value for the P max and the P mod STC, PMP STC same value, which is the 240 watt, and the PSP, the P start hours for a year, which is 1720 hour. And then the F temp. Okay, the F temp I mark it as equation number 1. So F temp is not given directly. So you need to find it based on the previous chapters we have learned already. How to find in F temp equal 1 plus temperature coefficient of PMP. Okay, what is the value of temperature coefficient for PMP? It's written here, which is the minus 0.45 over 100 because percent written here. Next is the T ambient, is the ambient temperature, whereas the ambient temperature is 32 degrees C, so this is 32 plus, and OCT is given here 47 degrees C, this is 47, and then the G value is the solar irradiance, which is the 800 watt per square meter. Then you put here 800 here minus TSCC, which is 25, and then you get the value of 0.847. Okay, next is the FMM. What is the FMM? FMM is equal to 1 minus tolerance. Okay, here there's two value of tolerance. One is the minus 3 value, and then the one is plus 5 value. So which one should you choose? Okay, here's very easy. We are going to consider the worst case. Worst case means minus case. Minus means if for example, if we have the module of 100 watt, minus 3% means at the peak time as the best condition of the PV module, the best performance, 100 watt, they may varies from 97 watt. Mean the minimum, even consider the best performance, which is the P max, it's not only 100 watt. Maybe they will drop, fluctuate from 97 because minus 3%, and plus 5% means that plus 5. So means the module of 100 watt, that 100 watt will varies from 97 to 105 watt. So this is what we call the power tolerance. Okay, the power tolerance. So in this calculation, we are consider the minus one because the lesser one, the lesser value. It's okay if you get the plus 5%, it's better. We just want 100 watt, but they give us 105, so there's no problem with that. But if they give us 97, that's quite significantly affect to your entire system. That's why we're considering the minus value here, which is 1 minus 3%, or 0.03, you get 0.97. Next is the dead factor, the equation 3. So the equation 3 is coming from the f dirt. Okay, f dirt is 1 minus dirt factor here is 2%. So minus 0.02, you get 0.98. The next is the fourth equation. So 1 minus voltage drop. Voltage drop is given here 3%. So you get 1 minus 0.03, you get 0.97. Okay, 0.97. Okay, next, the fifth one is the inverter efficiency. However, okay, the inverter efficiency here is not given. Why? Because there's still not the inverter. You're not going to choose the inverter yet. But still, you need to calculate the end total based on the requirement given. So what should you do here if the end inverter is not given? So we assume the value of inverter efficiency as 95% or 0.95. So when the value of inverter is not given, when you're asked to estimate the total numbers of module based on energy requirement, like this question, so you assume it as 95% or 0.95. So the all calculation will be here. So all the value are substituted here. Then you're going to get the 32.650000 dot 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 something like that. Okay. So what should you do? Okay, same process as the first criteria and the second criteria. We cannot leave in the decimal places of the numbers final answer as the final answer. Okay. So you must round it. In this case, we are going to round it up to become 33 modules. If you still remember, for the case of first criteria, which is design based on the area, roof or the land area, we round it down. Okay. Same case for the second criteria also. We round it down in order to estimate the solar module based on the budget. Because budget is given, so you cannot round up. So if you round it up, you need to add your own money. That's why we round it down. So within that limited budget, you can buy that certain numbers. Okay. But in this case for energy requirement only, we are going to round it up. Okay, round it up. Again, another two criteria, both are round it down. But for the case of energy requirements, it's round it up. The question is, why is round it up? Okay, the term of we must meet the yearly energy requirement. Same, you have to achieve that certain numbers of megawatt hours within a year. If cannot achieve that, you are going to be penalized by the electricity provider, because we have made it already. You have made a contract already. So we cannot get less than that. Okay? The key point here, you cannot get less than that. So you must achieve that level. You must have 32.65 module in order to achieve the 10 megawatt hour of energy yield. It means that what happens if we round it down? If you round it down means you are going to get 32, right? 32. Okay, let's say if I replace the value, I reverse all the equation, I put a 32, what will happen? You are not going to get the energy of 10 mega hours. You are going to get 9.978 blah blah blah, maybe something like that. So we cannot achieve the target if we round it down. When you round it up, confirmly, you're going to get 10.123 blah blah blah, maybe. So mean more than 10 megawatt hours. So we cannot get less than that. That's why we round it up for the case of this third criteria. Okay, I think it's clear already. Okay, you must achieve the target of energy. Like if you get below than that, you're going to be penalized. That's why we round it up. If we round it up, then we get more than 10 megawatt hours of energy yield. Okay. Alright, so in this model, we have determined the total number of PV modules that is required based on the selected sizing area. So the final number will be dependent on the selection of the inverter and the specific number of modules that can be connected in series and parallel to the inverter. So this will be covered in the next module. So the total number of modules that we get from these three criteria is not the final answer. After we finish this part, then we're going to matching voltage or voltage matching. and inverter PV area matching. So on that side, there will be revisions of a new total number of modules that you can install. Okay, all right. Thank you.